thank you all for making it back on time after the break. This next presentation is going to cover the area of station setup. And as we've heard over the last day and a half, that is the relocation or setup of a station is not an easy process. And it starts all the way back at the planning, determining is a new station needed, what should it monitor, where should it be located, and on and on and on. So hopefully with this presentation, Jaime is going to be able to demystify some of the process and help us get through that. So Jaime Contreras is with the San Luis Obispo County Air Pollution Control District. And Jaime has been a air quality specialist with the monitoring division of the San Luis Obispo County Air Pollution Control District since 2011. In 2013, he managed a 6-month PM10 field monitoring project that employed the saturation technique that involved the siting and operation of 25 EBAMs and 5 permanent BAM FEM monitors. Before joining San Luis Obispo, Jaime worked for 8 years with San Joaquin Valley Air Pollution Control District. During 4 years as an air monitoring supervisor, he managed the network of 16 stations, and he coordinated several monitoring construction projects that included the final shutdown of those stations. So please welcome Jaime Contreras.
Thank you, Patrick. He made already a brief introduction of what I'm going to say, and saves me some time. There's been some changes in the schedule. So, sorry. Since there's not going to be a break, I'm sorry. There was supposed to be a 15-minute break, but you just used it. So, what I'll do is just probably give us, 1 minute to stretch our legs and whatnot, maybe quick run to the bathroom. But I was also hoping to have an intermission, to have a Q&A session, because it's going to be a lot of information that I'm going to pass on here on to you. So please write your questions, and I'll get to them. I think I'm pretty good at that. Also, I want to thank every presenter ahead of me, because they already had given up information that I was supposed to cover in mine, but it's been already done. So I hate to be redundant, so I'm just going to go through it and hopefully get you, out of here just in time for lunch. Okay, so it's going to be a long one. Okay, what is this thing? And let me just get organized. Might not need this here. I would like to acknowledge our good friends Reggie, Laura, Wendy, and Matt, and thank them for their sharing of their knowledge. This was fundamental for the making of this presentation. So thank you, guys. I hope you are all here. Okay. Here are some important goals, and what we hope is that you take home some useful information in setting up monitoring stations. So I'm not going to say why you have to. You will eventually run into that situation. So for those that already done this, I hope they can give me some feedback, and so we can enrich the knowledge that we are sharing here in this presentation. And for those that have not had the opportunity to set up a new site, I hope they can appreciate the complexity and hard work invested in setting up a new site. So at the end of the presentation, I think you will have a better idea of what is needed to be considered for and to reach to the point of planning for a new site. Too much paperwork. So this is just a disclosure that we don't want to confuse anyone in thinking that this presentation is a substitution of any official EPA or CARB guidance. This is just a supplement to aid you in the process of setting up a site, or at least to give you an idea of what goes into setting up a new station. So, what we will talk is about 5 elements in the project of setting up a new site. Each one has lots of details and logistics to be covered. So, site selection, siting requirements, location, people involved, budget, logistics, building requirements and specifications, station setup, instrumentation, and most of you are already familiar with the monitoring station and its components. So, but we will talk about it just to cover the purpose of this training, and since it is the basics of air monitoring. And yeah, everything you wanted to know about this subject and we're afraid to ask. Okay, so just to make it official, here are some references that we utilize to put together the presentation. And here are a couple of names I might include in case you have, questions and need to contact or send me comments or criticisms or anything. Okay, so air monitoring. Yeah, we kind of learn something new every day. I feel bad every day if I go home and I don't feel I learned something, feel kind of wasted day. So today, we're going to learn something like, air monitoring, like ball juggling. It's kind of fun when you have lots of stuff on your hands to juggle at the same time. I think keeps the air, the day goes by more interesting. Okay. So in my view, this is the optimal group of people that should be involved in a project like this one. If they're not available, what you see on the screen, that means there's more work for the project manager and for that, or for those participating in the project. And what you see there is indeed a group effort. Okay, this is a busy slide. So we have 5 whys and 1 H. The why, the where, the what, who, when, and how. We will discuss these elements in this presentation. Hopefully, we all learn something from it. Okay, Gail's presentation already touched bases on some of this stuff, so as you guys know, you guys need to get EPA's approval for modifying your network. So after you went through the length and extent of obtaining the approvals for it, the project manager should engage in developing a project plan. The general flow will include these steps, I think. However, the order in which they will occur will vary per project. And trust me, hardly nothing ever goes according to plan. So just be flexible. That's air monitoring, kind of typical. All right, so the project manager needs to be prepared for a busy time. Yes, we love that. On top of the routine tasks and duties, running a project like this will make your day go faster, or sometimes it will not. You just wish to go home. Here are some skills that will be useful to have or to develop, okay? And you will look like I there. I'll try to put a picture of me, but I'm not glamour material like Bill. Okay, so here's our main goal for siting a new site. The closer we get to achieve this objective, the best representation of the pollution from the target area we will be, obtaining. So Eric gave us a lengthy talk yesterday about the scales and details and all that stuff. So, but I still have lots of information to cover. So in the next 14 slides, we will talk about site selection process. So in determining the need to locate a new site, the objectives and the scale will be determined as they will help narrowing down the siting criteria requirements. All right. I have a question. Does any district here owns the property in which they have their monitoring stations? I didn't think so. Oh, you guys do? You guys just ruined it for all of us. All right. Well, you guys are an exceptional group, I'm sure. So great. The majority, as you guys can see, doesn't. So we have to lease or rent or do some sort of arrangements for this. When we face ourselves in dealing with these entities, private or public, we encounter unique challenges. And both situations have some pros and some cons at the same time. So we will talk more about that, later. But it's going to be useful to know as much about these challenges, so in order that we can negotiate a more favorable lease agreement. Private property. So you guys over there tell me if I captured this wrong. So here are some things that you may already know. So I just want to add that if the site will be located in a private property, I would recommend negotiating at least 90 days or more, okay, to vacate a property upon 30 days notice of lease termination. It's kind of hard to get that, but you really have to use your contracting, negotiating skills to get that out of them. The goal in mind is to have as much time as possible to do a proper shutdown calibrations and or to do parallel monitoring at an alternative location. And also the shutdown audits, we need to bring up the audit team to our site if needed to do that and do the proper documentation. As Jason mentioned yesterday, you can get kicked out of your site any given time. So the public property. So for sites located in these type of places like water district, yards, fire department lots, or airports, there is still some additional terms on the lease and permits negotiating needed to be done. Mostly are complicated by security issues and restricted access. So beware that such lease agreements require county planning and or any of their board's approvals. So, and that could take some time or several months to get resolved. So just be prepared. This could cause unwanted delays, and just be prepared. Schools. We love schools. I like them, but sometimes out of pain. They're great places to have a station, and they're good partners. And so just a comment about constructing in school grounds. The school board approves such projects. Sometimes dealing with the school's architect can be complicated and may add unforeseen construction requirements. For example, you may need to have an extended fencing area. That's the total site footprint. This will be because they fear, Met Tower falling, want to protect the children. But when you went in thinking about monitoring, designing your site, you didn't count it, on that. So that definitely is going to change your plans and add your cost. Also, there's a DOJ background check that may be required, and if not clear, this may carry the staffing consequences if access to school grounds is halted. Okay, so I'm still in the site selection process, but changing a little bit of gears. Consider using any available source of information for identifying pollution sources. The following images are a couple of examples mapping important information. Pollution sources, sensitive groups, and characteristics of area pollution levels. And the lower left, the map depicts locations of interest, receptors like schools or hospitals, and sources at the same time like oil rigs and oil wells, including highways nearby. I just want to point out that I know that South Coast already have a monitor, nearby. And on the lower right, the old model, it's an old modeling map, indicates peak areas of ozone. And South Coast already have, at least that I know, 6, maybe somebody from South Coast can correct me, at least 6 monitoring stations that are in that critical area. Okay. Another tool is using websites that offer meteorological information to better understand the appropriateness of the area to locate a monitoring station. So, for example, information about annual average temperatures, wind directions, wind speeds, mixing heights in relation to topographic map is very useful. There is a website for this slide. From the same website, this is another slide of meteorological annual average information, cloud coverage, more wind data average per month. This additional information will give you a better idea if the investigated location meets expectations. For example, if you're downwind or upwind, or will you have good potential photochemical reaction or not, and other considerations to have. Okay, meteorology models or meteorological models like CANSAC can help predict wind data to further enhance the site selection process. CANSAC is the California, Nevada Smoke and Air Committee, which is supported by various agencies, including the U.S. Forest Services, the Joaquin Valley PCD, ARB, USDA, National Park Forest Services, Fish and Wildlife, the Bureau of Land Management, and much more. And the website is run by DRI. So for those that are not familiar with wind model representations, each tiny little mark indicates the wind direction and speed intensity. So in this case, you can see the bar on the right indicates that the green coloration is for the strongest wind areas, and the white they show stagnant wind conditions. So this is just another tool. And for further analysis from adequate staff, it could help narrow down the most suitable area to locate a site. And that's the website. Okay, Google Earth offers a ground elevation profile. This is a tool that will give you an idea of the terrain roughness in relation to the prevailing wind direction from pollution sources. In this example, the profile belongs to one of my sites in San Luis Obispo County. The profile depicts the surface roughness that a PM dust plume travels until it is measured by a BAM PM sampler. Along the path, the plume encounters dispersion resistance from geoformations and vegetation. So when evaluating such terrain characteristics, that will help you characterize the PM readings for this particular location. Also, Google offers you in the software, changing satellite imagery to previous years. So you can observe surface roughness and urban footprint changes along those years. All right, Caltrans. Hey. So continuing site selection process. So to assess the traffic conditions closest to the target location, use the latest road traffic conditions or traffic counts available. So somebody was asking earlier about that. So you can use the Caltrans Department of Transportation or your local county website, or use your local COG. Knowledge of the AADT is an essential siting criteria element. So Eric also mentioned that importance on his presentations yesterday. Census information is extremely important for projecting town developments and population growth. You need to look into the future, polish that crystal ball as much as you can. All right. Pollutant transport Yeah. The trajectory of pollutants is also important. In case you need to set up a site in a corridor and need to monitor for transport, effects. Wind pollution roses from established sites can provide additional information and seasonal information as well. The high-split models can provide a theoretical reverse trajectory of a pollutant. And all this information can enhance your knowledge for selecting an area to locate a new site. Or like Eric said, you've got to blame the other guy. Lastly, this is a checklist that was put together and we can share with you guys. It's just as a tool, okay, for tracking the completion of tasks when investigating and or evaluating the site selection and setting up a new site. Okay, so I'm going to switch gears here to siting requirements. As you guys know already, per EPA Volume 2, a minimum of 270 degrees wind arc should be obstruction-free, and this section must include the prevailing wind directions. Determining compliance with these criteria can be done various ways. You could survey the site in person and further validate your observations using wind roses from nearby sites or meteorological source data or using the web links that I shown earlier. It is critical to personally evaluate the area and detect potential pollution sources that could impact the site's readings. So, plan to position the site and inlets at adequate distance from the roads and try to anticipate road expansion for at least 10 years. Okay. All right. Continuing with the siting requirements. So occasionally remote incidents like the ones shown here, in this case the wildfires, they're shown to have a great health impact over populated areas. So knowing seasonal wind patterns could allow you to better determine a location that could assist with monitoring during these certain emergency events. Busy slide, but you guys already heard about this stuff, so you guys should be now familiar with 40 CFR Part 58. And this table just basically, gives you details on the criteria and road and inlet distances, information. All right. So even after long days and many hours of work investigating a suitable location, it is possible for ending up with a site that does not meet 100% of all the siting criterion. So contact EPA. Okay, and discuss the possibility to obtain a waiver that will still allow you to construct a site. So don't give up, all right? All right, now another change in gears. For the next 7 slides, we will talk about station requirements. These are more specific to the actual structure. You guys have an idea, for example, when you're planning for this, how many individuals will be, working one given time at the particular site? You guys have that into consideration? How many persons will be on the roof at once? How much equipment? How much total weight combined? We have auditors, we have the technicians, we have the auditing equipment, the site equipment, and on. We have lots of stuff. So how much collective information you have, it will help you design your station. Shelter should be comfortable to work in and with rather easy and safe access to the roof. So I am including here a note about the Americans with Disabilities Act, because the majority of the sites are not visited every day. And they are not considered work, and they are they are considered workstations. We just recommend avoiding descriptions that may indicate that they are offices, unless they are intended to be an office. Remember that ADA requirements will complicate the design, the permits requirements, and the constructions. If they are not considered ahead of time, they will cause expensive budget overruns and delays. So let me just go back here. Having a plan B is a good thing. Now, it's not required, but alternatives should be considered in case of project derailments. So I will give you an example in just a moment about plan B. These safety concerns are pretty much self-explanatory, but often economics tend to minimize their importance, and sometimes they are overlooked. Just remember that OSHA is everywhere. There's our requirements, not just EPA or ARB. Get your safety officer involved, if available. If not, again, more work for your project manager to investigate. All right, still on safety. So, this is the welcome to the neighborhood sign, a message painted in a brand new site that my good colleague Wendy, Caruso just finished constructing, and there it is. But I believe no welcoming committee showed up so you didn't have any reception there. But anyway, I'm just here showing some recommendations for making your site a little safer. Okay, so continuing with the station requirements. So most of us are familiar with the site using a trailer. So just notice that wall partition. I don't want to blind myself. That's the partition. These purposes are, to reduce the area, but reduce the area that needs temperature control, and also separates the area, providing the site operator with a comfortable place to have a workbench and do his, repairs, and keeping him, separated from the noisy side, because those pumps inside could get really, really, really noisy, particularly some stations more than others. Okay, here we have a modular compound as another shelter option. These drawings are from a San Joaquin Valley constructed site about 5 years ago. There are many details to describe them, but lots of work went into designing this shelter. No noticeable exterior ladder. It was kept inside for security. So this is the 4 views around, so you don't see the ladder. There is a hatch here that indicates the ladder is inside. We use steel grating platforms that were built on the shelter for anchoring roof instrumentation, so no drilling on the roof was needed. Also, notice here that is a hoisting equipment to bring stuff up onto the roof. Now, about the plan B, okay? We didn't have one when this happened, so I'm sharing this for you to save you some headaches. When we were, this shelter ended up with 2 doors. You see that? The front and the back? 2 doors. We didn't intend that. It was not original design. But it happened to be the case that was needed because the lease that we just signed with the water district, we were still in the midst of the construction project, and they just canceled it. They had grief from the neighborhoods there. They didn't like us. They didn't want us there. So the water district felt it had no resource and terminated the lease at that moment. Okay, so we had no site to go. And what we wanted to do is, we needed a location for this site, and not knowing where we were going to end up, we wanted to keep the door away from the prevailing winds. So we didn't know how the layout of the site was going to be. So we needed a second door because we didn't know how we're going to do it. Well, as you might guess, the back door, rear door, ended up being the main door, the main entry door, after we've scrambled around to find a new location. So it was nice to have management support and a little bit extra money in the budget to absorb that kind of expense. But it's not always required to have a plan B, but consider the potential. So if you guys can, go ahead, have a plan B. That's the door. Forgot to click. Okay, electrical considerations. We're still in the station requirements. Utilities are the blood of the project and need to be provided and any issues resolved. Consider the proximity and availability of these items. The further the distance, the higher the cost to bring them into the shelter. Okay? So one recommendation, try as much as possible to have your own electrical meter. Having to negotiate the consumption of these utilities in the lease agreement can and will complicate things, so they may not be too favorable in your lease agreement. And I keep forgetting to click. So we'll be talking more about this stuff later on. Okay, still on the station requirements. Consider that many counties require fire department disclosure of and approvals of hazmat elements stored at the sites. Check with your local county or fire department. These requirements may be triggered by your own insurance carrier. Also, as mentioned before, in deciding location in public property, the Department of Justice background checks are many times enforced and may impact abilities for staff site access. This is when you are located in public property. All right? So just as a footnote here, don't forget to furnish sites with the MSDS binders. So this is the last the slide for the siting requirements. So there was supposed to be a break afterwards, but we're going to keep on going. So this is a limited access example that I came across. In this example, the audit van has no direct access to the site. So I believe this is or was due to a lack of agreement in the lease contract. The problem is that the audit team has to park outside the property and park as close as possible to it. They have to park right here. And then having to be walking around the site because the entrance to it is in this end. And they have to do multiple trips back and forth, to get readings and do whatever they have to do. The aerial view shows that the lot has plenty of space for them to park. But because they had no item negotiated in the lease for vendors or other service providers access to it, then they can't. So just keep in mind when you guys negotiate your lease agreements about granting them access. All right. So we're supposed to have a here moment for questions, but I don't know how am I doing in timing. Have another 40 minutes to go. Do we have time for some questions? At this time, any questions? Making it easy. Thank you.
I have a question. How much was that beautiful trailer that you talked about, that Shelter One built for you?
Well, the one that with the second door, higher up the price, ended up costing that in itself about $120,000. That's lots of features that, I'll need about 15 minutes to talk about all the features that were into it to build the station. All right. Well, the picture and the introduction of the presentation is one of them. So they're very expensive, but you could get a more cheaper model for about $45,000 to $50,000. Okay, Phil?
Have you ever considered, or have you ever investigated?
Hold up for the microphone.
Is this live? Okay. Have you ever checked out using DC air conditioners rather than the wall mount AC air conditioners that just gobble up energy?
No, we did not at that time. We just went straight forward with the
I would
AC.
encourage people, if you're starting up sites, to check that out. I know at Mojave, at that air monitoring station, they've got a DC air conditioning system, and I've checked it out with electrical contractors and AC contractors, and it really reduced your electrical costs. So anyway, check it out.
Thanks for the tip. All right. So, we're supposed to have a 15-minute break, but we wasted it already. So, if anybody needs to get up and stretch, your legs, go ahead. We can give ourselves a minute, or we can just continue. Just do it? All right. All right, we're jamming the brain. Okay, so we're supposed to be a quick recap. I might skip that because 15 minutes, we forget lots of stuff. But so far, this is the things that we have talked about. And this is pretty much what we are looking forward to talk in the next 20 minutes or 30 minutes or so. And then after that, I guess it's lunch. Who knows? Okay, so now we're going to touch briefly on the station or the structure selection. I think we're all familiar with the typical roof setup for the FRMs or the Met Tower only systems or a complete side trailer or modular shelter or office setups. And that picture on the right, lower right, that's the actual picture of the drawings that you saw earlier. So you can see there's, I'm going to touch bases briefly here, but there's lots of extra ports that were, planned ahead because for future expansions. And lots of, upgrades on the roof to allocate for potential monitors to be brought for special studies. And there's more stuff inside that obviously we don't have X reason to see, but there's more. Okay. So weather. Weather can be your friend or your enemy, but the weather is a big player in determining the type of the structure to be selected. Metal containers will last a long time, and they're very safe, among other benefits. However, keep in mind that their walls are metal and very hard to penetrate. And drilling the walls may cause a spark, okay? Or you may even need to use a torch. So just remember that using fire in your stations is not a safe thing to do. All right. So plan ahead, with the holes and how much you want to project future needs. The picture on the bottom shows that having some heating source and it's a good, and good insulation is a good thing to have. It's highly recommendable. Okay, so in this case, this site, without it, you could have problems with controlling the room temperature, and that may lead to potential data validation issues, and also may not be too comfortable for the technicians or the staff to work, on that site. Lastly, consider that it may be necessary to procure staff with a four-wheel vehicle to access, that kind of locations. So it's not just the site; it's how we're going to get there. All right. More safety. In determining needs for shelter elevation from ground, you need to consider the climbing, risks. And procure safeguards to protect those climbing the ladders. Climbers can be site techs or service providers, such as the QA teams or others. If there's no risk for flood in the area, it may be okay to place the shelter on the ground, at ground level. One element that is almost always forgotten is the provision for hoisting equipment, that can be either bulky or too heavy may cause, as you may imagine, some physical injuries. So consider options for installing hoisting devices and needed structural support, support for these hoisting devices. So still with the station selection, okay, secure enough leasing space for all exterior equipment and plan various access points, as well as a large enough shelter to accommodate all expected equipment, storage, and for potential expansion needs. The picture on the lower and left is just a very nice mobile unit, a picture courtesy of Bay Area. Just as a comment, if you plan to have one of those or build one of those, make sure you have the appropriate vehicle to haul that around, okay? So that's, again, not just the structure. So at this point of the station selection process, you should be pretty much deciding what and where your site is going to be. And after considering station and site requirements, the construction project may look a little too complex. So I agree that it will be appropriate considering to contract out, the construction project. It may be necessary to make some cost analysis, comparisons and discuss the pros and the cons. We will mention some of those, a little bit ahead. And also, it may be possible to carry out a mixed construction project. By that I mean that a portion of the project will be contracted out and the other will be done by district staff, if available, and it has the qualification. And this is a practical approach and it's a money saver. So in moving into an office, make sure that there will be no issues with storing chemicals or gases at the site, and you will be able to punch holes on the roof, make whatever additional modifications to the office. Lastly, if installing an outdoor enclosure for a BAM or a TIOM, discuss the complications of servicing the equipment under adverse weather conditions. For those guys already doing that, you know what I'm talking about. It's not nice servicing out there with rain or 100-degree weathers or, strong winds. It's complicated. If in need of vendor information, you may contact our PQAO coordinator, Mike Miguel. He'll be able to share with you contact information of staff that have dealt with construction projects, or you may contact me and I'll be happy to share my experiences and tell you a couple stories at the same time. You can join something new that was just recently developed. It's a Google group. That's the name, and you can email Carl Tupper. He's the administrator of the group. He'll be happy to include you in the group and enrich all this exchange of information. All right. So let's take a look at some of the pros from both options. Building your own site or contracting out a turnkey project. So you can see saving money and building the way you want it and building a team exercise. And from the turnkey side, you don't have to do much. You just have to ask what you want and somebody else builds it for you. I mean, that's nice. You could have a legal, a contract to, protect yourself. And you almost count that the project will be completed on time because you have language in the contract that will, assure you of that. So those are nice things to have. They're nice and appealing. So on the cons, side, this is the problem. Okay, but we don't have a choice. Either or, these two options are going to happen. You decide to build yourself, you got to deal with these problems. Delays, backlogs, missing learning opportunities. Deadlines get pushed. I mean, a site that was supposed to be finished in 8 months turned out into 3.5 years project. So it's not, I mean, when you do your annual employee evaluation, that item seems to keep coming back. And it's not good to have that in your record. So, and the other side, it's expensive. Of course, they are. And depending on your area, the location, what you want, etc., is the price you're going to pay. Okay. Let's see. I'm going to be changing gears here. So in the next 8 slides, we will be looking about the station setup options and recommendations. These have a huge impact on the station design and the total construction cost. Okay, so we will be talking more about them. And the last red line, yeah, when you build a new site, you have an opportunity to have a clean, well-made, put-together site. Don't build a rat nest. All right. Okay, this is a recommended manifold gas sampling setup. What makes it through the probe cal check is the connection from the gas diluter output, sending the gas on a specific gas mix to the inlet probe. And the instruments then, connected to the manifold, pull down the gas mix to be analyzed. Okay, this setup simulates the normal atmospheric sampling conditions. And during the audits, this is the process, through the probe process that they utilize and expect to conduct. So when you design your station, do it with the site operator in mind. Just a few recommendations for your consideration. All right, these site setups drawings are courtesy of Bay Area. Thank you. To the left illustration, that exemplifies a modular, shelter. This is a much more compact than the one I showed you earlier, but it's still, efficient. It houses everything, keeps everything under temperature control. It is nice, but you could not have more than 2 technicians at once, probably in the shelter. But keep that in mind. The right illustration is an example of what appears to be a full station in an office building. I'm not sure if I'm right or wrong, but Glenn or Eric or Bob can correct me on that. Is that an office setup to the right? No? What is it? It's a trailer? It's an ample trailer. Okay. So we're still in site setup recommendations. Okay, these recommendations are self-explanatory, but they are often overlooked, and their consequences can be, of great, importance. Clicking. Okay. While you read, I'll drink some water. All right. So continuing with the site setup recommendations. Some instruments are best placed on instrument racks using the rack, the sliding rails or sliding trays. Others are better, placed on shelves or tables like BAMs or TIAMs. But if the BAMs or TIAMs are on shelves, the sampler should be restrained from movement in order to prevent leaks from the inlet, connection. Just please note that the recommendations about avoiding, avoiding the air conditioner vents blowing directly into the inlets or the instruments is critical, because that could lead to performance issues. So in some cases, the samplers could be tracking the changes in temperatures inside the room during normal sampling conditions, or during nightly calibration checks. And I'm not sure if you guys have seen that problem, but it's quite frequent that it happens. Okay. I have an example here of a station that I thought it was a good example of a well set up site. This picture is an example of a station in Turlock. The PC, this is in the Central Valley, by the way. The PC is in front at eye level. It's not seen, but it's right here. The keyboard is there with the mouse. And there are a lot of good stuff here. So, for example, the AC vents are not on the sides. They're on top, on the ceiling. The BAM is on the shelf, also easily accessible for the site operator to work on. The lights are over, and they're a good quantity. We have plenty of outlets, nearby. That helps us avoid having to run extension cords. There's a storage closet in the back, helping things, separated, kind of neat. And overall, you have access in the front and in the back for the operator to work around it, and for more than one person to be there at the same time. All right, so we get into the good stuff. And I'm going to change the subject to the shelter design for the next 11 slides. Okay, this is an important slide because I think it will cause some good and productive discussions. And to start, I have a question. How many of you have continuous PM samplers? Okay, almost over than half the people. What guidance do you run them according to EPA temperature control specs or per the manufacturer specs? There's two. Okay. So a while back, the Met One acknowledged that the room temperature swing greater than 2 degrees increased the uncertainty of the PM measurements by up to 2 micrograms. The TMs experience some negative numbers if concentrations are very low. This is due to the moisture condensation and evaporation effects. Also, these fluctuations in temperatures will also cause problems or effects on the nightly calibrations for the gases. This is the Met One chart elaborating on the sampler's improvement made to the older BAMs samplers, minimizing the effect caused by an 8-degree swing in temperature, room temperature. So if your sites have room temperature fluctuations between 20 and 30 degrees, which is kind of normal across the board, the resultant data is still valid, and this is also per the guidance that EPA gives us. The conditions for more accurate resultant concentrations are greatly improved when using the smart heater and when the room temperature control is tightly controlled. Keep in mind that these changes in room temperature will vary the relative humidity on the tape, and talking about the BAM tape, and this may affect the resultant mass concentration calculations. The red line is the hourly temperature, room temperature average. Okay, the green line, I can see with these colors. Which is the green at the top? Yeah. The green is the resultant BAM's PM concentrations calculations. The blue line, the bottom, is the PM concentrations corrected by filter temperature. So these temperature swings have a direct impact on what the actual concentrations will result from your BAMs. When you correct the temperature, room temperature inside the shelter, you could see the differences now between the calculated and the corrected is minimal. So the temperature control inside your shelter is critical. Avoid having to more than 2-degree swings, from hour to hour. That will really improve your calculations, specifically, particularly for the PM 2.5, since the annual average is now, this 12.5 micrograms. It's critical to obtain, more accuracy at that low level. All right. All right. To something less controversial. Lighting. But still on the shelter design. This is nice and clean. This is another picture from Bay Area. Thank you. Easy to work. As you can see the layout. The technician has access all around. Not much overreaching, having to get into a crowded rack. Perfectly nice tables to work on. So I really love this kind of setup. If you guys have the space and possibilities to do it, I'll recommend it. The only pointer I have is trying to secure them. And I don't know, maybe Eric or Glenn can tell me, or Bob, are those secured to the tables somehow? Maybe. Okay. And just avoid, I visited some sites and I found that some of the fluorescent lamps are these 8-footers. Hate those. Okay, they go out and you can't replace them. And they ask the technician, just go buy another one and replace it. How? How you carry that inside your truck or your car or whatever it is? It's going to break on you, and then you have all that stuff in your car. So just get the 4-footers, setups, and they work a lot better and a lot easier. All right. So more shelter design stuff. So here's a breaker panel. So label the breakers, all right? I have encountered situations that I'm troubleshooting an electrical problem and nothing is labeled. And I'm trying to just shut down something, and I have to go through every single stupid breaker trying to get to the one I want. So just label them. Common sense, I think. Consider supplying power to the audit van, that this will prevent them from running their diesel electrical generator. I think the benefits of not having them to run or having a diesel exhaust, nearby here, it's not a good thing to have during your audits. So if you guys can afford it, great. So it's something that you guys can discuss with ARB about the needs for how much amperage and what type of receptacle is what they need. Okay. So continuing on the electrical shelter design. So avoid outlet overloading and design a multi-phase electrical distribution to prevent it, okay? With so many pumps, samplers, air conditioners, running all at once, it's easy to trip a breaker or just amp overload. So it is very common to cause interruptions during a PM when you have a FRM sampler operating, and this stuff happens. You just lost a 24-hour run, and that's what we've been talking about, trying to prevent it. So designing your electrical load at your station, is a good idea. I believe, Laura, I think you told me the 50 amps service is what's needed for you guys to connect, right? 220, 50 amps? All right. And, yeah. Okay, so continuing on shelter design, avoid the extension cords thing. I think we all done it. I've done it. I'm guilty, okay? But sometimes I have no choice. I have shelter already designed for me 20, 30 years ago, and keep bringing more instruments, and it's difficult to avoid these situations, but when you are designing a new site, avoid that as much as possible, okay? So install properly and distribute those electrical outlets around, make them accessible. I think it's also a good suggestion to protect the equipment that is worth thousands of dollars, not just the computer. All right, through the probe. This is the CalCheck setup diagram from the EPA QA handbook, the volume 2. And as you can see, there are many benefits of using this type of AutoCal check setup. I don't know. There's still a few, I believe, using the manual connections, but we'll talk about those two right now, what disadvantages they have. This is the manual QC check setup disadvantages. Biweekly cal checks are minimal, and these are required. Sometimes, well, the techs, I believe they're all pretty good on keeping up with the good calibration results, but there is always a potential that something will go wrong. And when that happens, you ended up invalidating a lot more data. And I think we've been talking about trying to preserve data completeness as much as possible. So going back to the automated system, that's all allows you to invalidate probably a day to maybe no more than a week. So the manual checks, they have a lot of potential for more data invalidation issues. More shelter design. This has to do with the digital to analog conversion. Low-level electrical noise may account for 1 to 2 millivolts in noise. And in some cases, the difference could be greater. This is when the voltage range is set up as from 0 to 1 volt. It's more noticeable. So in those cases, 1 millivolt will equal 1 ppb or 1 microgram. And again, going back to PM 2.5, 1 microgram, could be a big difference on the annual averages. So the alternative is, if you're going to design a new site, try to go for a digital system. The digital incorporates direct communication with the instrument for interrogations, capturing internal parameters, metadata for diagnostics, and such data facilitates tracking of internal settings and parameters that allows the technician to monitor trends and using the information for performing more effective preventive maintenance. And basically what you see in the display is what you get. There's no adjustments, there's no slopes, intercepts, it's just what it is. This is the last on the shelter design slide. Here are some recommendations and comments. Laura is going to be touching bases, with great length and details about the residence time, so I'm not going to bother on talking too much about it. Okay, so now that we have an idea of what is wanted in a new station, we will talk about analytical instrumentation and related recommendations in the last few slides. So EPA has a big list of FRM, FEM designated monitors, and CAR, has its own, and that's the California approved samplers. And we talked about the differences between having one or the other. If it is not supported by the QA team from CAR, even though it's EPA approved, having the QA assurance is going to be, very difficult, to have. So the PQA thing that we're trying to promote here is more standardization on the instrumentation. So when purchasing, incorporating new equipment, work with CAR, look at the list, and make sure that it is supported by the audit team. Here are just the links for both listings, the EPA and the CAS list. And to keep up to date with the instruments issues, there's a couple of ways, actually more than that. You guys learn about the website the ARB has, which is great. I loved it. I checked it out last night and it was really easy to navigate. So thank you very much, and kudos to those that work on that. The AMTAC meetings, we haven't had one in a while, but I heard they're coming back. So please, come back to those. And CAPCOA air monitoring calls, also there's another way to stay in touch and participate or chime in with issues you want us, alert us all and share information. That's another way to stay in tune with this equipment issues. Okay, so just to reiterate what was said before, here are some common issues that I put to your consideration. Preventing them will eliminate complications in your construction project. Sorry about this. Okay, we're almost over. We're almost done. So here's a nice service available from CAR. They have staff and resources that may carry out acceptance tests. Check with the PQAO coordinator, Mike. The goal is to ensure equipment is operational before deployment. For pre-deployment testing, avoid, if you don't work with CAR, if you want to do your own, just avoid doing this test on the live stations. You know, these could complicate things, and you don't want to have those kind of tests there. So, you know, talk to them. They're very great about that. Okay, so what should you budget for? I think we have pretty much covered all aspects that we are ready to estimate the total cost of the construction, project. I never touch much on figures, but if you have some experience to bring your own, you may have an idea how much does it cost to put together a site. So here are a couple of suggestions and other comments. In my experience, every project is unique and will present different challenges. So with that, the cost is going to vary. All right, there is no one recipe for all situations, so it is important to remain flexible. All right. Keep everyone involved in the loop of things and have them communicate their needs and concerns before you move forward. The last thing you want is delays due to lack of communications. With that, I think that you are ready to start a new construction project, maybe. Who wants to say me? I'm not sure. I wish that someone had told me this stuff before I did my own construction sites. It would have saved me a lot of headaches. But anyway, live and learn. All this information could be used to support details when writing the request for a proposal for the construction project. The RFP should be detailed when describing the shelter type and specifics to the point that it leaves no room for confusion as to what is expected to be delivered. If and when writing a contract, a timeline is also highly desirable in order to avoid unwanted delays. Please include recourse terms for correcting problems or resolve discrepancies. If you have access to a legal department, a lawyer, they could be your best friends at that moment. So if not, I don't wish you bad luck, but good luck. All right? Lawyers could be your best friends at that moment. Okay, so as already been drilled into your brains, documentation. Documentation is key. So please remember to update all QC documents, including your annual network plans, quality management plans, etc., including AQS, which is not an easy, fun thing to do, but it's necessary and often is forgotten. And yeah, AQS is fun. Initial audit. Yeah, pretty much when you have a site already pretty much up there and ready and spitting out numbers and data, you want to make sure that it's operating right. So you want to have the initial audit. And by that time, CAR already knew about this stuff going on, and they're sort of scheduling ahead of time a visit to your site, and they'll give you their blessing, and you'll be good to go. All right? So this is it. That's it. Questions?
You talked about the variations, the temperature fluctuations, how they affected PM 2.5. How do they affect ozone?
Ozone. When the temperature changes inside, if the air is blowing directly onto the instruments, you're going to see this tracking. You're going to see this up and down, and when you have an hourly average, is going to average those ups and downs. So we end up lower or even higher if your temperatures are above 30 degrees. So that's where the effect would be. And during your nightly calibrations, you could also have a lower response due to the humidity. Wow. I didn't order that. It was not in my part. It's not part of my presentation.
Jaime? I had a question. I've been waiting to hear the answer, actually. I read that CFR on the sighting, and I thought basically what I saw was from your probe inlet. If you have, I believe it was off the horizon, I forgot if it's 15 degrees or 30 degrees off the horizon, you swing that around, forms a conic section, and if that's open, you're good. Can you tell me a little bit about that?
Nope. News to me.
Used to be?
It's news to me.
Oh.
So, Laura, you know anything about that?
Yes. Okay. From a BAM, from a probe inlet on a building, if from the horizon you come up 15 or 30 degrees on both sides of the probe, or one side, I guess, and then swing it around in a radius, it's going to form a conic section. And if everything in there is clear, you're good.
I believe Hansa Hansa calculated that for us. Go ahead and demonstrate that for us, Hansa, how you did that.
Yeah, you're looking for obstructions that are basically, if they're one tall and twice as far, and you clear that, you should be clear when you sweep that. But then that, if you've got tree limbs that are within 10 meters, that supersedes that. So it's kind of the hierarchy of these rules that you have to look at.
A 1 to 2, is that 30 degrees?
It ends up being about 26.5 degrees. It's not a nice straight number, but 30 is close enough.
So, Hansa, you're saying, okay, it's clear. We'll say, I think it's 30 degrees, but anyway.
Well, it's 2 to 1, which actually, when you plot it out, it's close. It's closer to the 30 than the 15, for sure.
Okay, so is that good? And then you swing that around, and you got this conic section above it, and it's clear of obstructions. Then you're good. Is that right?
Unless you've got limbs that are within 10 meters, from what I understand. That supersedes that. Even if those are closer in but above the probe height, then you've got the drip line rule that takes precedence at that point.
I'll talk to you later.
Yeah,
Right. So the two requirements that are actually the ones that are in play here are you want to be far enough away from obstructions so that it's not impinging your flow. And the way the regulation describes that is being twice as far away as the obstruction is tall, and that's where this 26.5 degree angle comes from if you do the geometry to figure that out. And then the other, and you have to weigh that both with your distance from trees as well. So you could have a tree that's not an obstruction for the 2 to 1, but it could be, and so it wouldn't necessarily be obstructing your flow, but it could be too close for scavenging and other things. So that's why you have to weigh both.
I think Laura has a slide on her presentation that addresses some of that, about the trees and the angles, if I'm correct.
Yeah, I'll have a graphical slide on that at the end of the day to wake you up.
Over there.
Got a quick question. It goes back to that conical rule. Is there a limit, a distance limit to that?
I defer to my
Yes.
ARB folks.
Go to Laura.
They hold the wisdom.
No, if the object's sat high and you see it in your arm going up, it's going to be too close. Considered too close. It's going to be it'll equal the 2 to 1 ratio that I'll talk about later.
Okay.
Yes, go ahead, Chris.
There was one consideration I wanted to mention, something that we ran into when we were purchasing equipment and things like that. When you have a site, especially in a rural location, that you're going to install, if you're going to have the site configured for 220, you have to ensure that you actually have available to you, because you can get 220 either in single phase or 3-phase, and you have to make sure that the power lines that come to your site actually are capable of providing. And generally can provide single phase. Not often do they provide 3-phase. So if you end up with equipment that's 3-phase, but you've only got single phase power, you're
sometimes you end up
trouble.
having to install your own transformer.
Right.
And that's the only solution, which you have to consider that.
And that can be a big expense.
It is an expense. I bought one refurbished, was $40,000. So
that's a big chunk of the budget.
It's a big chunk. It was refurbished, not new. So keep that in mind. Yes.
Regarding the 24-hour or 1-hour temperature plus or minus 2 degrees C, is it both 24-hour or 1 hour?
You would. There's a requirement, that you keep the 24-hour standard deviation no greater than 2 degrees. That's per EPA, regulation. But what we've seen with the BAMs in particular, from hour to hour, a swing greater than 2 degrees is going to have, an impact on your concentrations. So when you're measuring high concentrations, really it doesn't matter probably. But when you are in the low end, like in the 2.5, that becomes critical. Okay? That's the effect. So you're trying to minimize that by keeping those temperature swings to a minimum.
Hi. This is more of a comment for anybody that's planning a site rather than a question. I had the state fire marshal visit my site one time, and I learned something new about rooftop equipment that just didn't occur to me. And that is the picture up here is a great example. When you've got a lot of equipment, we had some equipment that was on extension cords. And the fire marshal said that you're not allowed to use extension cords on mounted equipment. Then the native power cord of that instrument has to reach a hard line that's wired as part of the building with the GFI connection. And that you may not have a fire marshal ever visit you, but should there be a fire, and particularly at locations like where there's schools, you could have a huge liability issue. So when you're planning that, make sure that you have wiring for the locations where those instruments are going to be.
Yeah, that's what I mentioned, dealing with the school's architect, because they have to review your plans and approve them. Sometimes they're a pain, and they will add a lot of requirements to your project, and you have to consider that. So we love schools, but be prepared to deal with those, extra expenses. I mean, if you're trying to do everything according to code and properly. That's it. Thank you.